Happy Monday. So we got a couple things today. Did you want to talk about the project? I thought it might be worth going over quickly for the project. I ended up making a video because with the midterm and everything else going on, I didn't think anyone would watch it. Is that okay? Uh, scroll. There it is. Uh, so we're going to start on arrays and vectors today. We've got lots of time to talk about arrays and vectors. They're lots of fun. You're going to love them. Promise. Um, and then we'll get into project 3 as well, which will use arrays and vectors and streams, and it's a lot of fun. That's unreasonable? Okay. Did you want to go over the midterm questions, or are we okay waiting on that, or we can do whatever? You guys are as tired as I am today.
You said I was
I'm sorry?
right on my psychology midterm, so I can
You had a morning midterm?
yeah,
Oh, ouch.
get my lessons.
Gross. All right. Well, let's start up. Let's do project 2. We'll do the hangman. Oh, did I already have one there? Did I start a project 2? I did, right? I did. I just have to open it. There we go. Yeah, look at that. Project 2, my recent list. I should pay more attention. All right, so these are the different functions we were looking at. And this was the minimum, right? This is at least you need this. You might have come up with other functions that were helpful too. Like, hey, is there a letter in a word or in a string? Because you end up doing that one a lot, right? That sort of thing. So just that's okay. We could figure that part out. Um, so excuse me. To print the gallows, that one was kind of boring. I think we'll skip over that one. Is that okay? We'll look at the more interesting ones. Is the letter guessed is in the hidden word? Oh my goodness, I can't even spell these functions. You guys didn't tell me that double is? It's all right. I'll just be an idiot up here for you guys. That's okay. It's good examples. So is this letter in the hidden word? Right? This kind of actually works for anytime we want to check if there's a letter in a word too. So instead of doing all this stuff here, right, we can say for index is 0, index is less than my hidden word dot is it size dot size index plus plus, right? Go over every letter in the word, right? And then we can say, hey, if the letter guessed is equal to the hidden word at the index. No, no, don't log into BattleNet. Don't need that right now. Return true. If we found the letter at one of these indexes, it's in the hidden word. We can return true, right? This was a pretty straightforward loop. This is just a one loop. And if we don't find it, after we've looked at every single letter, we can return false. No, it's not there. Okay. To get a letter guessed, right? Make sure it's one letter and make sure it's not in the letters guessed. So we can see out and say, hey, enter a letter to guess, something like that. Sure, it's really close. And then we can have a char for a letter, and then we can see in the letter. You can do one character at a time if you want. Now, I think we said, yeah, we're going to return a character, so that works out well. If you wanted to get a string and check the length of the string, you could do that too. You got lots of options here. Um, a string might be easier here, string for input, because when we get their input, then if they type in more than one letter, it's going to kind of jam up our buffer. Like if they type in apple and then they hit enter, like it might be a little confused. But either way should work okay. So we can say while the input dot size does not equal 1, that's one invalid piece here, right? And then that's invalid or something else is invalid. So we can say or, and now we can actually cheat and reuse this function here, right? So that's my input dot at 0. That's the first letter, right? Because I need a single character, right? Input at 0, and then the hidden word then would just be my letters guessed. Right? We can reuse this function here, and I think I need one more parenthesis. There we go. This should probably go down below that, right? I'm gonna make sure it goes underneath this function if we're gonna use that function. Oh goodness, edit, advanced, format. Where's my format? Isn't it format document, E and D? No, why didn't it move it in? All right, can it just all pull in? Okay, that's fine. So get the letter guessed. Is it not matching right? Or okay, that one matches. I don't know why it's upset right now. What did I do? Expected a semicolon. Did I take out one of those ones? I did. All right, I don't know what I did wrong there. Sorry, that's super weird. Control E and D. All right, reformat. Anyway, so if this is true or this is true, right? If either one of these is true, we want to keep on going. If this is not true because it is size 1 and this is not true, the letter's not in the word here, then I can end my loop or not even run the loop at all, right? Uh, Now we could tell them why it was invalid if you wanted, or like we could be a little bit more specific. Sure. We could say, hey, if size is not equal 1, tell them only one letter at a time, or this gets to be a little bit tedious, but it's fine. Enter only one letter at a time, please. Sure. And then we could say, hey, if letter's guessed, or parentheses. Yeah, you already guessed that. Now, none of that was like required, but this is just nice to, show your users what's happening rather than just prompt them again. That's okay. Or if you just wanted to say, hey, you only guess one or don't repeat, up to you. However nice you want to be to the person typing at the keyboard, that's up to you. It's your program. When it sucks and they don't know what's happening, they're going to blame you because you wrote it, right? Sure. All right. And then when we're done, we can return my input.add0, right? To make that string turn back into a character because we're saying let's get one character at a time, right? Kind of works that one out. All right. And then display the hidden word. This was a loop within a loop, right? So this one gets a little bit funny here because I'm going to loop through the hidden word and I'm either going to print the letter or I'm not going to print the letter. Right. So again, I think I've got a loop for that already. I don't want to repeat here. Let's see this one here. There we go. Okay. So first loop now for the hidden word. Now I'm going to assume we haven't found the letter until we do find it. So I'm going to make a new Boolean variable here and say, I don't know, letter guessed is false. We'll say, okay, we're going to assume you haven't guessed the letter. Then I'm going to loop through all of the letters guessed here. Or, right, we have a function, right? We could do a double loop, but you're doing more work than you need to. So let me just move this down one here, and we can skip all of that. We can say, hey, if the where is it here? Is letter guessed in the hidden word, given the, I need the hidden word at the index, right? This is the letter we're looking at. And then if that is at, or is in the letters guessed, right? That there is a, that there, that there and there. Um, this is true or false, right? If I've guessed it, right, but I'm flipping it around now. I'm saying, hey, is the letter in the hidden word in the string of the letters I've guessed? And we can reuse this function. We're doing the exact same check every time, and you don't want to do more work than you need to. You're lazy, right? You're a good developer. Okay. It's okay if you didn't do any of this. That's you could repeat yourself multiple times. You're not going to lose points for having done more work than you needed to. You just did more work than you needed to. That's all. Right. And if that wasn't obvious to you, please don't feel bad at all. Right. I've been doing this for almost 20 years now. So some of these things just like make sense in my head because I've been doing it for a long time. Right. And these are the sorts of things you learn with experience. Okay. So if that letter is there, then I'm going to see out the letter. And I'm not going to do an end line, right? Because I don't want to go down a line. And I just want to smush all these things together here. If that's not the case, right? If I did not find the hidden letter, then, right, I can see out my underscore. And that's it, right? The pseudocode, the loop within a loop that we had was valid and would perfectly work. But this function already does a loop, right? So we're doing a loop, and then this is the loop inside the loop, right? We just have a function that says, is this character in this string, right? We've already figured out how to do that, right? And then has the person been hanged? This one is really quick. We can return number of incorrect. No, I think most people, when I talk to you, you'd say something like, if my number of incorrect guesses is equal to 6, right? Your head, your body, your left arm, your right arm, your foot, and your other foot. You say if this equals 6, return true, if else return false. Don't do that, right? Because you're saying if true, return true, just return it. Oops, right? This here is a true or false statement. You can return something that's true or false, right? Otherwise, you did more work than you need to. But again, that's okay. Um, but this will either be a true or false statement, right? You can even say greater than or less than equal to 6. I don't think it matters at all one way or the other, right? And has the word been guessed? Now, this one was a little different, right? We're looping through, and every one of them has to be guessed here. But again, we've done that work already here, right? So let's not do it more than once. So we can loop through for the hidden word, uh, basically this one here, right? So if the letter is in the hidden word, so we want, if it's not in the hidden word, return false, right? If there's a letter in the hidden word that's not in the letters guessed, we return false, right? My little knot here. If I've gone through this entire loop, right, and I haven't returned yet, if I haven't returned false, I must have guessed everything, right? If I get through every word and I haven't returned a false, I must have guessed every letter in the hidden word. I can return true. So check every letter in the hidden word. If it's in the letters guessed, great. We don't return false. If we find one that's not there, right, because this would be true if it's not there, return false. So just lots of loops within loops, but our function again does a loop, right? And then what did I do here? Turn. Didn't I have this one typed out? I think I must be like hitting my cut and paste too fast or something weird. Let's see. Okay. And then get a word, right? We made sure it was at least 4 letters long, right? So a couple options. I'd like, if you can, make the loop run. So I can say, hey, my string for, I don't know, the word starts off as blank here or something. And while my word.size is less than or equal to, no, less than 4, right? Because word here is less than 4 for sure, right? Because it started off as empty. So then I can get some input, right? So I can see out for a word to guess, at least 4 letters long, and line, and then I can see in on word, and eventually we'll get out of that loop and return word, right? Okay, this one was, I think, pretty quick. We've done a lot of the validation loops already. And Zybooks has made you do, can't talk today. I think I need a little more coffee. All right. What do you think? So the last thing we did was the print gallows here. I think did I give you a starting gallows in here, right? Oh, thanks, Edge. I like that. Hangman with functions. Yeah, here's your little gallows, right? So we can just see out. What was the trick to get the multi-line string? Do we have to just do it all individually? That was really annoying if you have to do it all individually. Like this on every line. And Endel. Oh my goodness. Okay. Well, we can do that. And Endel. Oops, no semicolons. That's why. That's why. All right, this is really boring. Sorry. We'll be quick. Why this? It's spacing out funny here. It's messing with my faces. I think you got the idea for this one, right? And then once you put that in the quotes, right, you've got a single backslash. You have to escape that to get an actual backslash, 2 backslashes, because reasons. End line, one more end line, another end line, and then the last one. Why is there like a weird gap there? Weird end line. Okay, now a semicolon. And again, if it's 0, print it without a head. If it's 1, do it with this, and so on and so on. If you're sort of incorrect guesses, 0, right, without copy. I just don't want to have to copy paste a bunch of stuff right now. Is that okay? All right. So it should work. Let's try it. See what goes for us. Uh-oh, build errors. No matching token for int. Is that where I was missing my? Yep, there we go. Excuse me. All right, enter a word to guess, at least 4 letters long. So let's try like ape. No, at least 4 letters long. Okay, so that seems to be working. What letter should we, or what word should we guess? Coffee? You guys took too long. Uh-oh, it stopped. All right, well, something's not working right. Let's see. While not has the word been guessed, hidden word and the letters guessed. Has the word been guessed? So this must have ended then, right? Because our whole thing ended. We never even printed the gallows. Let's put a breakpoint here. We did something wrong. Coffee. Let's step into our function to see what's happening here. So the hidden word, once I step in, hidden word is coffee. The letters guessed is blank. So let's see. And the letters guessed is blank. Okay, so let's step into that one. Is the letter guessed in the hidden word? Is this in the string of the hidden word? Let's see. Hidden word size. Oh, is the letter guessed in the hidden word? Oh, okay, because we're checking every letter. So C, O, F. Oh, that's the F. That's another F. That's an E. That's another E. Why do we not return? Something's backwards on this. This one should have been returning false. What did we do wrong? Step into. No? Why didn't I? Hang on, I missed where I was going. Coffee. Debugging is definitely lots of fun. Okay. So this is has the word been guessed? So I want to step into this one here. So is the letter guessed in the hidden word? So the letter guessed was C, because this was the letter coffee here. Is that in that one? So this should not turn a true. Not true should be, I should have returned false. Why is it not doing that? So the letter guessed is the hidden word at the index. Oh, it's the hidden word at the index. This one never runs, so this one shouldn't run. Oh, my return is inside the for loop. I didn't notice that before. This return has to be outside the for loop, right? We've got it in the wrong spot. That's why it's failing on me here. Well, after we've gone through every single letter, then we can return a false here, because we were returning false every time. Let's try that. Hopefully that was it. Coffee. And let's continue. Okay, there we go. Now we get a guess. So that was it. We had the curly brace in the wrong spot. All right, so what letter should we guess here? A? Nope, not an A. Are we printing the display the hidden word? Oh, we hit the breakpoint again. We take that breakpoint out. There we go. All right, so nope, no A. B? No B. C. Hey, we got a C. How about an O? We got an O. How about an E? We got some E's. Should we hang the person? A, we already guessed that. B, we already guessed that. C, we already guessed that. D, E, F. And we got hanged. We lose. Maybe we want to tell them what the word is at the end. I think that might be nice to show them the word, right? So after this loop is done, we can see how the word was. Or if we were hanged, right? We should tell them what it is if the word got guessed. I guess we never printed it out anyway, so we should just see how the word was with the hidden word. All right. Anyway, that was the project. So using functions, lots of specific functions, lots of loops, lots of letters, lots of strings, those sorts of things. Does that make sense? All right. Pull up this one here. Here's project two. Oh, I don't need this one here. I think I was just testing here. Yeah, this was just being silly. All right, so there's project two. I'll discard those. All right, and push and pull. Okay, now we're in sync. Should we talk about arrays, the new stuff, and vectors? All right, start up a new project. This is chapter 7, arrays and vectors. 7, arrays and vectors. Now, arrays are very common, but they suck. Vectors are much more flexible. They take a little bit longer to get used to working with, but they're so much better. So if speed is important to you, an array is technically faster. Sure. For everything we're going to do in this class and everything you're going to do in next class, we probably don't care about speed. When you get to 350 for data structures, algorithms, and analysis, then we finally are like, hey, wait, speed probably does matter here, and we should do things efficiently. But for now, we're just trying to solve problems and learn how to solve problems. So I will mostly talk about arrays and then forget them because they irritate me. Uh, and I'll use vectors. If someone else says arrays are better, just go for it. That's fine. No biggie. They're not exactly interchangeable, but everything you can do with an array, you can do with a vector. So I'm going to use vectors because I think they're easier. So what is it?
Oh, like that group from Swivel and that guy.
Oh, yeah, I don't know. Some people have strong opinions about things. All right. Everything we've done so far, we've been able to store one thing in a variable. Right? A string technically was a bunch of characters. So that one sort of was a little bit of an anomaly, right? But integers and characters and floats and doubles are things, they only could hold one value. Now we're going to bring in arrays and vectors that can hold multiple values, and they're super handy. So if you want to hold a bunch of integers, we can make an array of integers. So I can say, hey, I want this integer array, and I use the square brace notation here. This will be my numbers. I think I've got the syntax wrong. I can never remember these. Where's my... Is it really just vectors first? Wow. All right, we'll do vectors first then. Sure, why not? I like vectors better anyway. So if to use vectors, we have to include them. We're going to say include vector. Now, vectors get some funny syntax, so we have to tell C++ what kind of value we're storing in our vector. So I'm going to say, hey, I want a vector, and then we use I call this the diamond operator, greater than and less than, to smush together here, of int. Here, so I'm going to say, hey, I want a vector of type integer. So I'm going to a bunch of integers here. I'll call these numbers, right? Then I can take my numbers now, and if I put a dot, I get a couple options. So vector is technically a class, so when you hit dot, you get some options. Well, we'll get more on that next chapter. So one of the things we can do to vectors is you can push to the back. We can add something to it here. So it starts empty, and we can start pushing back some numbers here. So we can add, say, 1, and numbers push back 2, and let's, add a couple more. 2, 3, 4, 5. 5's probably fine. So now in a single variable called numbers, I now have 5 values here, 5 integers, which is kind of handy. So if I want to use them, we use that same index notation or the same at notation like we did with strings. I said, hey, give me the value at this index. And again, they're zero based like strings. The first character in a string is 0. The first value in your vector is 0. So I can see out my numbers at 0, right? This is the first value here, right? We always start with 0. And as you can imagine, it's probably kind of tedious to do the 0, 1, 2, 3, 4, 5, and so we go with loops. So for int index is 0, index is less than numbers dot size, index plus plus. So we could see out numbers at index, and probably an end line, right? So I should get 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5. We got the 1 doubled, right? Because we took 1 out first. So you can put a bunch of values in, and we can get them back out one at a time without having to say, hey, I need the int first number, int second number, int third number, int fourth number, int fifth number. And now, hopefully, you're thinking this is kind of useful because if I ask the user to enter some numbers, I don't need to know how many numbers they're going to enter. I don't need to have 50 gazillion entries and variables for it. I can have a single list of numbers they can just add stuff to. So we can ask the user, hey, let's enter some numbers here until you're done. Use one of those sort of valid or the loops with a sentinel value. Like here's a unique value that tells me I should stop. Right? If it's a numeric value, sure, we could do that. If -1's invalid, have them enter -1 to stop. So we might say something like cout enter test score or -1 to stop. Oh my goodness, what did I just press? I don't want insert. That's a weird thing to put on the 0 key. And maybe we have an int for score. Can see in score. And while score does not equal -1, let's keep on adding the score. Right? So we'll take my numbers, push back the score. Let's add score to that numbers vector, and then we'll ask them again to enter it here. Oops, enter a score. Now, the only thing I need to do is make sure that it's not -1 the first time. I guess this is fine, right? So if it is -1, the while loop doesn't run. I add it. Then I ask them to prompt again. If it entered -1, the loop doesn't run, it never gets added. So as long as you're making sure that -1 never gets added, you're okay. I don't usually like to prompt first, but then I'd have to like check to make sure it's not something, and it gets a little messy. So anyway you want to do it's fine. And then again, we can loop through and find all those, or we could go find the average of scores and those sorts of things, right? Let's wait on this. Let's comment that one out for now. So we don't have anything there yet. So we won't have anything because its size is 0. It won't run. So enter a bunch of scores. Maybe we have an int for total. Now, when you loop through things like a vector, this is a lot of typing sometimes, right? It's not too bad, but it's a lot of typing. So if you only want to get the values out, you can get values out with the little, they call the enhanced for loop here. And I'm just going to Google it. C++ for loop. Because I don't remember how it looks. My goodness. Yeah, variable collection. Range-based for loop. Okay. So you give it the type here, a colon, and the vector. Because why not use colons more places? I didn't come up with it. So we'd say int, I don't know, value, or yep, value is probably fine. Colon numbers. Right? This is going to take each number in the numbers vector and assign it one at a time to the integer value here inside the loop. So enhanced a range-based for loop. Is that what they called it? Range-based for loop? Range-based for loop or enhanced for loop. Loops for each value in the vector, assigning it to the variable on the left. So quickly then I can take my total plus equal to the value. Value. Right? Go add it to the value. When this loop is done, I've now have a grand total. I can see how the average score is going to be, right? My total divided by my numbers.size. However many numbers they entered, great. I'm going to total them up, divide by the size. Right, now I can compute an average for any n length list of scores. You guys look very impressed. Sorry, it's Monday. But do you think we would have been able to do this without a vector? Could have. It'd be really, really, really awkward because we would have had 100 different variables we'd have to account for and figure out when you wanted to stop, right? That, it was near impossible to do this without vectors beforehand, unless we said, hey, enter 5 scores. We knew there's only 5. If we didn't know the number of scores beforehand, this probably wasn't going to happen without a vector, right? So now we can deal with things that are of variable length because I don't need to know how long it is. I just start jamming them in the vector here. Now, There is a limit to how many items you can put in a vector. It's mostly limited by your computer's memory. So I can fit gazillions of them, right, with my memory. So if each integer takes up 4 bytes, right, and then we got kilobytes, which is 1,000 bytes, then we got megabytes, which is a million bytes, and then we got gigabytes, which is a billion bytes. I can have billions of integers before I'm going to run out of memory on my computer, right? No one's going to be entering a billion numbers. Now, if you're dealing with files, maybe you got a lot of numbers in a file. You might eventually possibly run out of space. But again, we're going to worry about that in later classes because we're not going to do anything at the billions scale. Is that fair to say? Okay, so that's a problem we can solve later. Someone posted a really cool thing. I think it was in my Discord server. They were optimizing an algorithm and they were able to get it to go from like some slow amount of time to like under a millisecond. It's super crazy, and they did some really cool, smart stuff with it, which was really fun. So I'm glad people are into that sort of thing 'cause it's like a puzzle, and I guess it's interesting, but I would rather like solve problems than make things faster. But that's my problem, not yours. So all right, so let's see if we can average scores. Oh, build errors. Uh-oh. Total never. Oops, that's right. We got to start total off at 0. Before you can add to it, you got to start it at a value. Uninitialized, right? You never gave it a value. You never initialized it. Right. Enter a test score. How about 90 and 80 and 70 and -1? Average is 80, right? 90 plus 80 plus 70 averages out pretty good. I like that. All right, let's try. How about 199 and -1? Oh, we didn't get a double here. We probably want one of those two things to be a double, right? Because number size is an integer. So why don't we make double or total a double? That's all we needed to do. Now we'll actually get a decimal place, right? Because we're not doing integer division here. So 199, -1. Now we get our decimal place, and we're happy, right? Okay, just a cheap trick here, if you want. You can also do the casting thing in line. Cast it first as a double. I think this is easier, and we don't care if it takes up twice as much space. Like, I don't. It's okay if it's 8 bytes. It's not hurting anybody, right? I don't have a billion of it. Okay, so that's my vector, right? It's flexible. It lets me add things. Let's see, what else are we missing here then? Iterating through vectors. Yeah, loop through the vector. I hate I just call it index. Like, it's not hard. Most people use I. I don't because I like to be irritating about it here. That's all. Most everyone else in the world will use I. Plus plus I. Someone told me this is like ever so slightly faster than I plus plus, right? To prepend versus post. Whatever. I don't care. It does the same thing for us. Finding maximum value, minimum value. Sure, those are fun. Okay. Multiple vectors. This was when it starts to get fun here. So when we're dealing with multiple sets of information that aren't the same type. So you might have noticed here, this vector is of type integer. It only holds integers. What if I need to know like a number and a string? Like when we talk about building out our shopping list that we're going to write to files. If I need to know I need to buy 7 bananas, I can't store 7 bananas as an integer, right? I could store the quantity as an integer and then the name as a string. We could do that. So I can have like side by side vectors. We could do that. So we could have a vector of type int for quantities, and we could have a vector of type string for items, right? And then I can ask you how many and what item, how many and what item, how many and what item. And I'm just going to kind of keep them paired essentially because I know the first item in each are the same, the second item in each are for the same thing, the third item in each are for the same thing. Or maybe we even wanted to have a vector of double for price. Now, prices, sure. I think plural is generally the more common way to name vectors, right? Because it's generally multiple things, not just one. And then the individual item in it is the singular. So sure. So we could go through and we could loop and ask them, hey, enter how many and what it is and what the price is of what you want to buy and add it to our vector. And then we could get a total cost of your shopping list sort of thing. Can we do that? Okay, cool. So how about we say item, string item, is nothing, a int quantity equals 0, and a double for price. equals 0 to start. We'll just start all these off here. I can say while my item does not equal stop or something, right? Eventually they can tell me stop, right? And maybe what do you want to buy, how many of them, and what do they cost, or any sort of order you want here. We should be able to figure that out here. We'll see out. Enter the name of an item to buy. And then we can see in, oops, there's my semicolon. We can see in the item, and then we can see out, enter the quantity. We can see a quantity, the T, and then we can ask, enter the price. And we can see in a price. All right, and then I can add them all. Right, so I need to take my items, I need to push back the item if the item's not stop, I guess, right? So if item does not equal stop, it's not equal or stop to stop. I don't know. Is it kind of redundant? Well, I'll just say or stop. So the item's not stop, then we can go and push back all these things. So we'll take that one, we'll take the prices, push back, price, and then we can take the quantity and push back the quantity. So we can have these sort of like parallel vectors here. And I know the thing on index 0 is all for one, thing on index 1 is all for one. Um, then we can go through and we can find items and we can work with those items. We can get prices. We can print out like a receipt, all sorts of fun things we could do once we've got items in these paired vectors, right? We can kind of keep them together here. We can work with them together. Um, you can resize vectors if you want. Um, no, it's not super useful, uh, but sure. Now, if you were to try and access something that doesn't exist, so before, like I had commented this out, we made numbers, we never added anything to it. If I try and get something at an index and it's not there, I'm going to get this out of range exception, and my program crashes. These are pretty common as you start working with arrays and vectors because they will crash on you. They'll say, hey, it's out of range. You tried to get an index and it wasn't there. No luck, right? Go away. Didn't work for you. So that can happen. That's okay. Uh, but it means we tried to use something that wasn't there. So most often when we're looping through, if you say like less than or equal to size, you're going to run into that. Right? There is no index 5 when you have 5 items. You have index 0, 1, 2, 3, 4. So just be careful with those. So you'll see that a lot as you're working with it. So I'll leave that one commented out, but you can run into those. So if you want to resize your vector, you can shrink it down, sure, go for it, or you can increase it if you want. So then you can set values. This seems awfully awkward to say, hey, let's size it to 3 and then set 3 values rather than just push back, push back, push back. But that's okay. So once you have vectors, you can change the values at indexes too, which is fun. So if I wanted to say, hey, let's go through, I've got my average here now, and let's actually compute average. So double for average is equal to this. And now I'm going to go through and adjust the scores. So um, a lot of times people say you want your grades to be curved. Please don't ask for that. Right? Grading on a curve is a terrible thing. Right? So the standard um, curve can't even spell anything. My goodness. Where did it go here? Standard deviation curve? Deviation? Wow. There we go. Look, I knew what I wanted. So this is the standard deviation. If you ask to be graded on a curve, you're saying you want most everyone to get a C, right? 68% of people to get a C. That's what you're asking for. You want 13% of people to get a B and 2% of people to get an A. That's grading on a curve, right? That fits the grades to a standard deviation curve. You don't want that. Right? What you want is what most people say when they ask for things to be graded on a curve. They want the highest score subtracted from 100, that number of points added to everyone, right? If the best test score only got an 85, what you're asking for is, can you just count that as 100 and give everyone 15 points, right? That's not a curve, right? That's just bumping scores, but that's okay. So we're going to say, hey, let's figure out what the average is here. and let's give someone some points based on the average. Or should we do max? We can do max, right? Max is probably good here. So let's go through and find the max. So I'll have an int for max score. I'm going to start as, was it int min? Oh, sorry, int min. So starting this at the minimum possible value means something will be greater than it eventually. I don't know which one it is. So I can say for int score, int scores, if my score is greater than the max score, I have a new max score. Max score now equals the score, right? Numbers, sorry, this is numbers. I named that one badly. Okay, so go through every score in the numbers. If the score is bigger than max, I have a new max. Now I found what the max score is when I'm done, right? So now I can go through and if you use this sort of list here, this is read only, essentially. We're getting copies, right? You can't modify things with this sort of loop because we're getting copies here. So generally we'd use the index-based loop. So I can say for index is 0, index is less than my numbers, not size, index plus plus, and I can see out, or I'm sorry, I'm going to take if the numbers at the index is less than the max score, right? Actually, we're just going to adjust them all, right? I think we're going to adjust all of them. So we'll say numbers dot at the index. I'm going to add to it. What I'm going to add is 100 minus the max score. Right? Let's go add to every score, whatever the difference between 100 and the max is. Let's go bump them all up. Now, the problem is if you offer extra credit and someone got 105, you've now taken away 5 points from everyone. So just be careful. That's all. People would probably be upset if you take away 5 points because the max was 105. Okay. All right. Some of you look upset. And then we can go through and print out the scores again. Or let's go and average it again now. Right? The new average. Let's see what we get here. So let's not give a score of 100 because that won't cause any adjustments here. So let's do like the 90, 80, and 70. And then -1. Uh-oh. Oh, we didn't get the total again. I have to go through and calculate the total again here. Sorry. Let's go redo the total. So that was the old average. Let's go through and get the total again. There we go. Now it should actually change. All right, so 90, 80, 70. Uh-oh. Well, that's not right. Yeah, thank you. Yeah, yeah. Let's put total back to 0. Right, we just kept adding the total. Thank you. Put total back to 0. There we go. So 90, 80, 70, -1. There we go. So we bumped everyone up by 10 points, right? Which makes sense because 90 was the best before. So everyone got 10 points. We had 100, 90, 80. Okay. So that's right. You're just supposed to stop. So if you tried to do this sort of thing here, let's try it one more time here with the enhanced loop. Let's do it this way. So after we go through and find it here, let's say score plus equals 100 minus the max score. Right? Using this enhanced for loop here is not going to do what we expect it to do. I'm going to put a breakpoint in so we can watch it. So let's do 90, 80, and 70. We want to stop. Okay, so now we broke. We got to the breakpoint. So we have our numbers array or vector here, right? Which is super cool. And I can see the values at given indexes. I know it's a little small up front here, but you can open it up in debug mode and you can actually see the values here, which is amazing. I can see it's a 90, 80, 70. So as we loop through and I'm getting each individual score, now score is 90, right? And then go to the next one, the next one, the next one. I've looped through all of them, but now the numbers list here is still 90, 80, 70, right? You're getting copies. Score is a copy of the value from numbers. So modifying score in the loop here does nothing because it's not changing the value that's stored in the vector numbers, right? Because we made a copy of it. Like when you pass values to functions, generally we pass by value, right? Unless we specify by reference. Yeah.
Do you have like values set at 0 and 1? Would pushback just add to 2 or would it add to the 0?
It would add to the last item. So if you already have 0 and 1, now it becomes index 2 when you push back. Yep. So we'll always add to it. So pushback never changes existing items. Yep. And that's why we can just like loop forever and just keep on pushing back, right? Just until they're bored, we can push back tons of scores. Yep. All right, cool. So we got that one done. Let's see. Let's see. Vector pushback. Yeah, we did that one. We start adding things. Uh, should we wait on arrays then till tomorrow? So do you got to talk about the project? Okay. We got a couple, so we can talk about the project. Let me go fire up another link for you here. 53. This is project 3. Now this will be the last individual project, right? Before we get to the final project. I know you guys are so sad about that. So we're just cruising here, right? So we're going to work on this one in 2 weeks. It'll be due. Um, I think ideally we can get it done by the 13th. Um, should be pretty good there because that way we could got enough time to work on the final project. Should be much more interesting here. Uh, okay, cool. So yeah, yeah, the final project will have a month to work on. And if you can get it done early, even better for you, because that way you don't have to worry about it for final exam week. I know final exam week gets busy. I wanted to give it earlier to give you a little more time. I know Thanksgiving break we're completely off. Uh, Most people aren't busy that entire week, so hopefully you got a little bit of time there. I guess that technically doesn't count as a week because we're off, but uh, sorry. But if you want to work on Thanksgiving break, maybe you don't have to work on finals week. So you got that choice there. Yeah, and then we can do pointers, and then 10, 12, 4, 12, 6 is just for project time. In lecture time, we'll still do our lab on pointers on 12, 4, right? Because we'll do the pointers lab then on 12, 4. Um, yeah, I think that's probably how we'll make that work. So, because we'll do arrays and vectors today, arrays and vectors next Monday, classes. I think we'll have to do more objects and classes on the 27th. Then we can do pointers on the 4th. Those are big topics. Okay. All right. Anyway, so our project here. Oh, sorry, making a link. Making a link. Go back to this. Templates. Let's find that one. Right, so we're going to combine our vectors with files because we're going to be able to read and write some number of things out of files now that we have vectors. Right? We don't need to know how many specific things we need to read and write out of there, which is super fun. This will be project 3. 3, and we'll call this, I think, Ticketmaster. It's probably improper to use here, but that's okay. We're just going to make fun of them here. So we're going to build a little ticket sales program. So please submit the URL and of your repository. Include a self-assessment and screenshots of the program running in the README file. Okay. And this one, how many points do we do for that? I think this one's probably 20 points here. I'll make this one worth a little bit more as we go, because these should be increasing. You don't get to forget anything here. This will be the 13th. When class starts, make sure I hit 11 a.m. this time instead of 11:59 p.m. That was my bad. Okay, so 2 weeks from now. So we're going to write a program that allows the user to create and sell tickets for shows. So each show should store a list of tickets in a file. So this way, as we run the program, the data is saved there for the next time we run it. And the next time we run it. Now, again, in real world, we use databases. We haven't gotten there yet. So it's okay. We're just going to use files. We'll be okay. So give the user 3 options when the program starts. Option 1 is add a show. So to add a show, get the name of the show and create a file using the show name as the file name. Right? If the file already exists, tell the user to go back. Or go back. Like, so we don't overwrite here. We don't want to overwrite all their data here. So other than that, right, we're going to ask for the number of tickets available for the show. And we're going to put in the file here then. So we're going to write uh, n number or x number of blank tickets to the file. So the idea with the ticket, right, it's going to have a ticket number. It'll have the person's name, and then it'll have a 6-digit confirmation code. So when people show up and say, "Hey, I've got ticket number 7, my confirmation code is 1234566," and we can look it up real quick, make sure that it matches, they've got the right code, we let them in, right? This sort of thing. So the blank ticket then means just the ticket number. So these are going to be like sequential. If you have 100 tickets, you've got tickets 1 to 100. We're going to do 0 to 99. Sure, do 0 to 99. That's probably even easier, right? People would be confused with ticket number 0, but that's okay. We're computer people. We can confuse everyone else, right? Uh, Ticket number blank for name and 0 for confirmation code. That sort of idea. So if you say I want 100 tickets for the new Trolls movie, we'll now have a file with 100 blank tickets, right? That's option 1. So option 2, allow the user to sell tickets to a show. Ask them to enter the show name, and if the file exists, or if the file doesn't exist, tell them it doesn't exist or something. Sure, it won't exist. If it does, if it's there, we need to go out and read all of the tickets into a vector. Right? So if you have a show, like a file trolls.txt, I'm going to go read all of those tickets. So if the file exists, read all of the tickets into a vector and ask the user, or maybe we should tell them, right? Tell the user, sir, the highest ticket number they can purchase, ask what number they want to buy. So I said I read 100 tickets out. Say, okay, you can buy up to ticket 99, or maybe seat might be an easier way to think of that, like seat 1, seat 2, seat 3, rather than ticket number. It's the same idea here. So ask which seat do they want? What ticket number do you want? Yeah.
For this, you think we should add 1 to the vector? So it won't be like 0 to 100, it'll be 1.
You could do 1 to 100, you could do 0 to 99. It really doesn't matter at all. Whatever you want to do, but if you do 1 to 100, you're gonna have to adjust, right? So read all them into a vector or vectors, likely, right? If we're going to have multiple pieces of information, that idea of these parallel vectors, right? I might have one vector for seats, one vector for names, one vector for confirmation codes, right? I have to, if I'm storing multiple things, right? Ticket number, name, and confirmation code, right? So then check and see if that seat is available. That ticket number is available. So the confirmation code is 0. It's probably the easiest one to check, right? If the confirmation code 0, it's available. Cool, because we haven't given it yet, right? If it's not available, click again, is available, ask for their name for the seat, and generate a random 6-digit confirmation code, right? So that's 100,000 to 999,000. That should be a comma, sorry. 999999. There we go. Right, so a little bit of random math there, right, to make sure we get that right range. And then add the name and confirmation code to the appropriate place in the vector and rewrite the file. Again, this is terrible here. There are better ways to do this, but we haven't got there yet, so it's okay. So we're just going to blow away the file with the new version of the data. So here's the 100 tickets with one of them being updated instead of updating just that one line, which would be much better, but that's much harder, right? We haven't got there yet, and we're not going to do those advanced streams for now. So, right, that's option 2. We let them buy tickets or try again, try again, try again, try again. Option 3 is to run a show report, the show name, and display all the ticket information for the ushers to check people in. So just print out all the tickets. Ticket number 1, person's name, confirmation code. Ticket number 2, person's name, confirmation code. Right, we're just going to spit it all out to the screen. Does that make sense? Okay, cool. Let me publish that one. So using vectors and using files here. So let me add a rubric here for project 3. Use this one for grading. So this is our, let's see, so this is option one, create new show files. Do option 2, sell tickets from files. And then option 3, print show report. Let's do, this one's probably 10 points here. So the sell is a bit more advanced here, right? Create a new show, pretty quick and easy. If it doesn't exist, go and write it, a bunch of empty things. This is the harder part. And then part 3, you just open and read it and print it out to the screen. Okay? That's not reasonable. So we can do 20 points for that. So not going to be too terrible here. Just some practice with vectors, practice with files, right? Reading and writing them, those sorts of things. So we're not going to append anything. So we're going to take the lazy route. When we write the file, we're just going to erase what was there, put the new data in. So reading it is important, right? This idea that if I know how I'm going to write it, I know how I'm going to read it. Right? If you want to do it all in one line and do string streams and take those apart, that's probably harder. If you want to do line for ticket number, line for name, line for confirmation code for one ticket, that's fine. You can read 3 lines for every ticket. It's not too bad, right? Just read 3 lines, read 3 lines, read 3 lines. You got lots of options here. However you want to make that look, it's totally up to you. Okay. Uh, I think that's all we got. Sound good? So we'll meet in lab today. We'll do practice with vectors because vectors are awesome. We'll do a little bit of fun things with them, and then we'll go from there. All right. Awesome. Thanks, folks. See you for lab.